So we've got this Hebbian postulate. Cell A makes cell B fire, then the connection, and does it repeatedly, the connections get stronger. Is there sort of anything else that we could think about LTP? This is this long-term potentiation of synaptic strength, this kind of change in synaptic weight. Is there anything else that we can sort of say about it in general? Well, so one is input specificity, right? I won't say in order to be useful it must, but it seems like you're going to be able to store a lot more information if it's input specific. We'd already seen that in the very first paper on it, right? The other pathway that wasn't given the stimulus didn't get stronger. Here it's trying to show this in a little cartoon, right? This neuron is highly active and may or may not be making the postsynaptic cell fire. That makes the synapse stronger, but this other synapse is not strengthened. So we get input specificity. There's also an idea of cooperativity, right? So I've never seen a perfect physical demonstration of cooperativity, but the idea here, right, is that here is a this is actually an EPSC. This is an intracellular recording, but the point is that the excitatory input, they have two of them, S1 and S2. When they provide a input to S1, a tetanus, they drive it hard to make it, you know, induce LTP. If S1 is too small, they will not get out LTP. If S2 is too small and applied by itself, they will not get LTP. But if you apply them together, then they're strong enough, right? So you get this cooperation where if um, if an input is too small, it can't induce LTP no matter how hard it tries. But if it combines with another small, or potentially 3 or 4 or 5 small inputs, then they all will get LTP, which is very closely related to this idea, which is associative activity, which is just if you have one big one strong input that is big enough to cause LTP by itself, and it is paired with a very weak input that would never induce LTP by itself, then if the strong and the weak input both deliver a tetanus to the cell, the weak input is potentiated. So it's basically just like the cooperative, except it's a weak and a strong versus lots of strong, right? So essentially, when a strong input is putting a cell into like an LTP-like state, weak inputs that join in at the same time will also be potentiated. And that is a very interesting idea, right? That is very fundamentally different from um, well, it's I don't want to say it's fundamentally different from Heb because it's actually exactly the same as what Heb said, right? We've got the strong input and the weak input. It just says that if this weak input um, is helping make the postsynaptic cell fire, which it will be, right? So we it extends the idea from one strong input can undergo LTP. It shows that we can start sort of in a way, if two pathways are coincidentally active, then they can strengthen each other.